This lesson is on the geometry proof. So this is our last lesson for this semester, and we're going to use some more definitions. So one of the definitions we have constantly used is actually when we know two angles and we're looking for the third angle, we would add the two angles together and subtract it from 180 to figure out what our third angle is. But that method right there is called the triangle angle sum theorem right there. So if we continue to use any of that, know that the justification for that is because of the triangle angle sum theorem that you're using for that. Another definition we're going to use is the vertical angle theorem, which is very similar to when we did our two parallel lines and a transversal. So think of it as this right here being our parallel line right there and this one right here. And then we have is a transversal lines right there. So because of the transversal lines, we have vertical angles because the angles are opposites of each other. So it's the same idea when we have our angle BCA. So our BCA is congruent to angle ECD because of vertical angle theorem right there. Another definition we're going to use is the transitive property, which states that basically if you have A, B, and C, if AB is equal and BC are equal, then so is AC. If you're given an angle B and BE are equal to each other, if angle E is 50 degrees, then angle B would have to be 50 degrees as well because of the transitive property. The last definition we're putting in is the midpoint, which is similar to the lesson when we found the distance and the midpoint. To find the midpoint in the line BE, we have to state that BC is the same or congruent to CE right there, and also that the line DC is congruent to CA. And so because those lines are congruent to each other, then this point right there at C point right there is going to be the midpoint. So that's the definition of midpoint that you would have to use. Okay, and then what we're also going to do is we're going to go away from the flowchart and use the two-column proof. So which is the same idea. We're still doing statements, making some kind of statement, and then justifying our statement right there. So in our problem right here, example 1 says that this is given, C right here is the midpoint of BE and DA right there. And we have to prove that the triangle BCA is congruent to the triangle DCE. So what do I know? I know that BC is congruent to CE. I also know that DC is congruent to CA, so similar to that definition right there of midpoint. So I can put little markings or hash marks right there, because remember we said that this right here is congruent to this right here, and also this is congruent to this right here. The other thing I also know in this is that BCA is congruent to DCE because of the vertical angle. So right there, our angles right there are congruent to each other right there. And so this gives me enough information to say that the triangle BCA is congruent to DCE because of side, angle, side right there. Okay, example 2. We're given that angle B is congruent to angle D. So as we can see right here, angle B is congruent to angle D right there. And we have to prove that the triangle BCA right there is congruent to DCA right there. Okay, so information that I know is then the angle B right there is congruent to angle D because of definition of congruence. I also know that BAC right there, so this angle is what I'm speaking of right there. And since I can't just say angle A because we actually have two angles in that A, and that's why we have to name it BAC right there, is congruent to DAC right there, right? Because of definition of congruence. And again, because it's given to us with the markings, that's why we can say that. And then the third one I can say is AC is congruent to AC, because anytime the two lines share a line together, then it's called the reflexive property. And so right there, I'm going to make a little marking right there. So with that, then I can say that the triangle BCA is congruent to triangle DCA, and the condition is because of angle, angle, side. So here's my angle right there. Remember, I can skip, and then I can do another angle, and then immediately it should be my side right there. Our third example is that the angle A is congruent to angle C right there, and angle B is equal to 40 degrees. And we have to prove that the two triangles are congruent to each other. So I can say that angle A is congruent to angle C, and that's because of the definition of congruence, because that was given to us. I can also say that angle B right here is congruent to angle D right here because of the transitive property, which states that if I know one angle, then the other angle is the same. And then I can say that the angle AEB, so AEB right here, is congruent to DEC right there. And that's because of vertical angle theorem. So we can say then these two angles are congruent to each other. If I look at this carefully from my three statements that I made, I have as an angle, angle, angle. And that, I believe, is not one of the four conditions. Although this looks like it looks good, but that is not one of the four conditions. So because of that, our triangle BCA is not congruent to DCE. And the justification is because there is no angle, angle, angle conditioning. Some of the triangles will not be congruent to each other, as you can see in this problem right here, that the triangle is not congruent to the other triangle, and the reasoning because there is no whatever the part that you have, or because sometimes there's not enough information. So if they don't give us enough information in these triangles, sometimes they don't give us enough information right here, so you can't make any statements or justification. So because of that, then you just say that the two triangles are not congruent, either because there's not enough information or it's a condition that is not one of the four.